morning, students. Again, with the lecture series of abstract algebra, we will continue with ring and subring. Last day, we started ring and subring. So, ring and subring is correlated with the group and subgroup. Same is the further process that R plus with two binary operation R plus and multiples both are applicable in ring. So R plus should be a group, abelian group. If it is abelian group, then we call the commutative ring. Okay. The objective lecture to understand about the ring, know about the ring and subring, and understand the properties of ring the same. After the lecture, the student will able to discuss about the ring and which algebraic structure we can say ring for the R plus and dot. So let's we start the lecture. Let's start. With the theorem or a problem. First I write ring. In last lecture we discussed about ring. Ring means R plus dot to algebraic structure is called ring if for that R plus is a group first. Okay. Second, R dot have associated. And third, inverse element, identity element and distributive property. Distribution property or law. That is fine. Okay, these are the condition. And then yesterday we proved that z plus dot is equal. Okay, so so now we take some problem. We have the group where the set is have the other operation and other set like example show that the set of number given by where showed that the set of numbers given by a plus b root 2 where a and b are integers. वो इंटीजर्स हैं a और b इंजीनियरिंग हमें शो करना है कि एडिशन एंड मल्टीप्लिकेशन के लिए इस टाइप के जो एलिमेंट्स का सेट है ए प्लस बी रूट टू विथ रिंग सो नाउ लेट एलिमेंट then R that set is then abelian group first we show closure property because here A1 B1 A2 B2 are integers so A1 plus A2 A1 plus B2 so we can also element of so C1 C2 okay so we can write A1 plus A2 as C1 plus D1 this is the element no second thing let A2 plus B2 ये R से बिलोंग करते हैं we take three elements A1 plus B1 root 2 A2 plus B2 root 2 and A3 belong A3 plus B3 root 2 then associative property then A1 plus B1 root 2 plus A3 is equal to A1 plus B1 root 2. We can put here A1 plus A2 plus B2 plus, sorry, A2 plus A3, B2 plus B3. Now we can do A1 plus A2 here A3. Sorry. This is called, we can segregate with that by A1 plus A2 plus A3. We can write like that B1 root 2, B2 root 2, A1 plus A2 plus B1 plus B2 plus A3, B3 root 2. Now A1 plus B1 root 2 plus A2 plus B2 root 2. We can write A3 plus B3 root 2. And easily we can write A1 plus A2 plus B1 plus B2 plus B2. This is become, this is called associative property. This is follow. This is satisfied associative property. Associative property. Okay. Now we do identity element. Third is identity element. Identity element means if A plus belongs to R, then 0 plus 0 root 2 also belongs to R due to A and B belongs to I or ZK, we can say set of integer. So 0 is also belongs to I, so we can take A is equal to 0 or B is equal. Now, now for addition, A1 plus 0 plus B half plus 0 half multiply with 0 is 0, so we can say A1 plus B1. So, so 0 plus 0 half H identity. Okay, 0 is the identity element for addition. We know very well. Now we discuss about inverse property. Inverse property. Inverse property means that the resultant is identity element. So we know the identity element is 0. So let A plus B root 2 belongs to Vihar. A B belongs to in set of integer A. We know we know that if A belongs to I implies minus A belongs to I. If A belongs करेगा I के अंदर तो minus A also belongs to I. Similarly, similarly, B belongs to I, so minus B also belongs. That can, so we can say minus A plus minus A belongs to I because minus A minus B both are belongs to and R में वही एलिमेंट है जो A और B जिसके I में बिलोंग करते हैं then we can write A plus minus A. Okay, so here we get A minus A plus B minus A 0 plus 0. So so we control that R plus okay. So first property we satisfied that G plus is a group. This is a major property. Now we show that is abelian group or not. For abelian, for for abelian group, we have to show A plus B is equal to. Now take two elements in R. But which type of element in R? A1 plus B1 root 2 or A2 plus B2 root 2. So the element are let A1 plus B1 root 2 and A2 plus B2 root are in. So A1 plus B1 A1 A1 plus A2. So we can write A1 as A2 plus B1 root 2. Here we can write A2 plus A2 plus B2 root 2 plus A1 plus. This is equal to cumulative log. That means that means it follows commutative law. Commutative. Now, now friends, we have we already show we can conclude that R plus H and below. तो स्टूडेंट फर्स्ट टर्म तो हमने प्रूफ कर दी, ठीक है। अब हमें सेकंड टर्म की बात करनी है। सेकंड टर्म क्या है? एसोसिएटिव प्रॉपर्टी इन मल्टीप्लाई। ओके, तो वी कैन शो, we can easily show, we can write here R2 associative with multiple ऑपरेशन में एसोसिएटिव। ओके, सो A1 plus B1 root 2 A2 plus B2 root 2 A3 is equal to, we easily can do it by cross multiplication. So we can find here A1 plus B1 root 2 A2 plus B2 root 2 this is satisfied the associative or multiplication distribution addition. This property in the distribution law that A B plus A equal to A B plus. So we can take and take A is equal to A1 plus A1 root. B is equal to A2 plus A2 root. C is equal to A2. Now A means A2 plus B2. questions. Now we can write, we can write a1 plus b1 root 2. काफी लेंथी एक क्वेश्चन है इसके रिंग के, तो वी हैव टू प्रूव ऑल द स्टेप वेरी क्लियरली. We have to know about the first we have to show r plus is a group, then all the step very carefully do in the exam because each step has the value. Okay, so if you are right easily, then it may be deduct your marks. You cannot write directly. I will show you all the step very carefully. So a1 a2 plus a3 plus a1 b2 plus b3 root 2 plus plus d1 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 b1 multiply with this, so become b1. Okay, now b1 b2 plus b3 on root 2 dot. So here we can do a1 a2 plus a1 a2. Okay, a1 b2 plus a1 a1 b2 plus a1 plus b1 a2 root 2 plus b1 a3 root 2. Base become root 2 a3 b1 b2 2 plus b1. Now we segregate the term a1 a2 a2 a1 b1 2 a1 b1 plus b1 a2 on root 2 plus a1 b2 plus a1 a3 b3 root 2 plus b1 a3 root 2 plus b1 b2. Okay, now we can write here a1 plus b1 root 2 a2 plus b2 a1 plus b1 a3 plus b2, which can easily say that a b plus, this is the distribution. This is so this is follow, this is satisfied the Now, okay, now we see that R plus dot is a abelian group. R2 R dot has associative property R plus dot distribution. Now, now it can be concluded that R plus dot is R plus dot is okay. So we can easily again see. I repeat this question and explain again. This is important question to prove the ring. And in the BSc, BTech, BSc, MSc, this is very important concept. Many questions made by ring and very lengthy. So do it very carefully because you miss the any step. This is can be trouble for you. Okay. So show that the set of number given by a plus b root 2 where a and b are integer is a ring with addition and multiplication. So we see let a1 plus b1 root 2 and a2 plus b2 root 2 be two element of set. Then r1 the set of an abelian group. First we will show that r the condition is r1 that we have to show that the set is an abelian group. For abelian group we have to show the closure property. We take two elements of R and the multiplication or sorry addition of this element also in R. So R element have this type A1 plus B1 A root 2 and A2 plus B2 root 2. Then A1 plus A2 plus B1 plus B2 root 2 is also the element of associative property. Let A1 plus B1 root 2, A2 plus B2 root 2 and A3 plus B2 root 2. Then we have to show that A1 plus B1 root 2 plus bracket have important part. Here I change the ink for explaining. Here, here is. This is the separate part. We can explain it like that. A plus B plus. Now we have to show. So A we can take A is equal to this, B is equal to this, and C is equal to okay. We can also take to understand this concept. So we find a1 plus b1 root 2 plus a2 plus when we addition a1 plus a2 plus a3 plus b3 root 2. So it convert in a1 plus a2 plus a3 and b1 plus b2 plus b3 root 2. So by solving this, here we find out it can be write as it can be written as a plus 2. This can be written. As. 2 plus 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 Okay, so this is the associative property. So this is the associative property. Now identity element. Zero is the element of I, and we know very well zero is the identity element for integer. For I plus, we know that zero is identity. So 0 plus 0 we can call this add by addition. A plus 0 and b1 half 0, it become, again we get same 0. So we can say that 0 is identity. The inverse element has a plus b root 2. If a belongs to I, b belongs to I. We know that if I is set of integer is from minus infinity to infinity. So if 2 belongs to I, and so minus 2 is also belongs. So I write here a belongs to I, so minus a is also belongs to B belongs to B I, so minus B is also belongs to I. A and B are arbitrary element of, okay. So we can do easily minus A minus B by 2, when the addition is come 0 element. So, so inverse element, so inverse element exists. So we will conclude that R plus area, okay. Now take two element in R, let a1 plus b1 root 2 or a2 plus b2 root 2 are in R. Then a1 plus a2 plus b1 plus b2, this, and this is commutative property. So our commutative property is follows, so it becomes a abelian group. Commutative property means a plus b is equal to, if any group follow this property, then it's called the abelian group. So R plus is a abelian group. This satisfies R1 is satisfied. Now the second condition R2 associative with multiplication. We know associative means for multiplication. We can write here A B into C is equal to A into B. We can write like that. So we take A is equal to A1 plus B1 root 2, B is equal to A2 plus root 2, and A3 is equal to, sorry, C is equal to A3 plus B3 root 2. And when multiplication we get A B plus C. Now the multiplier distribute addition, where A B plus C is equal to A B plus C. So we put the A B C value and then solve. In exam you have to show all the step very clearly. Have to do. Sometimes students only write this equal direct answer. So not do like that, because you have to show all the steps very carefully and very clearly. For each step have the mark. So if you are not follow this process, so this will be wrong. You are wrong. Okay. When we discuss about the proof, then you have to show each step very carefully. Now, by the SP addition property, R plus is abelian group. R dot has associate property. R plus dot have distribution law. So after these three properties are satisfied by the ring, so we can see that R plus dot is a, okay. So student, I hope Eh, This is very beneficial for you, and this is a good lecture for understand the properties of group. Now, in next lecture, we do again some function. We will show the group or set of function. It also a ring. If have some property. Okay, some example because for show the ring is very important. We have to show if the algebraic structure is a ring. It is very important the aspect of examination. So each step should be clear with you. Now, now choose time. So I take you. I start quiz. Now clear to you. Very small question and interesting. Which statement is false? I already told you in algebra when each question have a statement and you have asked in exam, any competitive exam, he asks to you what is the true and false, more statement. And R is a ring, then unit element always exist. What do you think about that statement is okay, but it should not always be exist. Because if unit element exist, then the become ring with unity. So this is not always true. R has two operations. बिल्कुल that's the right. R has two operation. R has the binary operation, two binary operation, addition and multiplication. Identity element exists in R plus. This is definitely true because R plus is a group and all is true. So the first one R is a ring with unity. Then unit element. This is always not here. The word we use always. This is false. Okay, if it is not used, always word, then we can say okay, or it may be used R with unity. The distribution property. What is distribution property? A, B, C, A plus C is equal to. So this is say that distribution property is C plus. This is called the distribution property. But there is option already given none of this, so none of this we can say. But distribution property A B plus C is equal to AB plus B. Which statement is MZ plus dot is a ring? Yes, we have M is even integer, but here not written the M is not written any condition. So if we add that M is the even integer, then it is we can say that MZ is ring, always a ring. But M is not defined M. M may be odd. For odd number, MZ is never be a ring. So this is not possible because it is not in odd section. If M is odd, it not fulfill the closed condition. So we both are right. So we here change right here both B and C. This is okay. This is okay. Which statement is true? In normal suppose you follow cancellation law. X is equal to AX. The inverse element of H is the same. बिल्कुल and all are true. Questions all are true. So thank you very much for keep continuing in this lecture. And next lecture we will discuss more about ring and more example of ring. So thank you very much for listening.